Question 38. Here we are trying to understand our exponential function again. This is almost at the end of our quiz, and now we're just trying to understand whether we have really understood our exponential function or not. Okay, so we'll study the restrictions on the function. Question 38. Explain the following for exponential function f of x equals to a b to the power of x. So that is the general form of our exponential function. The question here is, why b cannot be a negative integer? And question number b is, why b is greater than 0 but not equal to 1? Okay, very interesting questions. And actually the chapter started from here itself. Therefore, we're trying to go back to this and understand why. So let us think that b is negative. And then let's try to plot. Okay, if b is a negative number, then whatever, let's say a is 1. Let's say some negative number, let's say negative 2, right? Let us assume that b is negative 2. Let's take one example and let's say b is negative 2 and then we have negative 2 to the power of x. Now, if I give x as 0, then anything to the power of 0 is 1, so I get a point here, correct? If I take x as 1, so minus 2 to the power of 1 will be minus 2, so I'll get here minus 2, right? If I put x as 2, then minus 2 to the power of 2 will make this positive and I will get 4. So at 2 I will get 4. So I'll jump here, right? And if I put x as 3, then minus 2 to the power of 3 will be minus 8, because negative 1 to the power of odd exponent will always be negative. So I'll get minus 8. So at 3 I'll get negative value somewhere here, right? And then for 4 I'll get a positive value. So what happens if I have a negative base? Then my values keep jumping between positive and negative, right? The function is no more continuous. It's kind of. It's not continuous at all, right? We don't know what's happening, right? Therefore, for exponential function, we cannot have b as negative, because if b is negative, then our function is not continuous at all. It keeps jumping from positive value to negative, negative to positive, depending on whether our value of x is even or odd, right? Because x is any real number here. So as soon as we get odd number, we'll get a value below, and for even, positive value, negative value, which makes the function discontinuous, correct? And therefore, we cannot have b as negative. I hope you understand that part. Now, well, we say b, and b should not be 0 either, because 0 to the power of anything is just 0, correct? So if I say b is 0, then what? If I say b is 0, then 0 to the power of x is what? It has got no meaning, right? 0 to the power of x is just 0, correct? Therefore, b is greater than 0, but not 1. Why? Because if I write 1, then 1 to the power of x is what? 1 to the power of x is also constant, right? X may be anything, but 1 to the power of anything will be just 1, and we get a horizontal straight line, right? We don't get an exponential function. Do you understand? Therefore, exponential function b is always, so b is always greater than 0, but b is not equal to 1. I hope you remember that part, right? So let me write it here clear in bold, that our base b should be greater than 0, right? And b is not equal to 1, correct? As you have seen, if b is negative, it oscillates between positive and negative value. And if b is 1, then we get a horizontal line at 1. Do you see that? Which is not exponential, correct? Therefore, for all other values, we get b as a function like this. Is it okay? That's how we'll get. If exponent x is minus, then we may get a decay like this. But it is exponentially increasing or decreasing. Correct? I hope that thing clears it all forever and you really understand the restrictions on the base b of exponential function. Thank you.